Hello everyone, and welcome to Network Labs. Today in this video, I will show and simulate eBGP configuration in a Mikrotik router. In the diagram, a Mikrotik router is connected to two different ISPs for redundancy. For our task, both PC1 and PC2 must connect to the Internet. ISP1 must be the primary path for both inbound and outbound traffic, while ISP2 as backup. Customer is assigned with an AS number of 13456 with 2/24 for ipv4 and 2/48 for ipv6. See network details on the screen for the one IP addresses and loopback. To achieve our task, follow the steps below. IP addresses are pre-configured to save time. Let me show you quickly the configurations. Connect to the router using Winbox. First is the description of each interface. Then ipv4 addresses. And ipv6 addresses. Before we proceed with eBGP configurations, let us conduct link connectivity to both ISP1 and ISP2. Let us proceed with the configuration. First to configure is basic BGP configuration. Initially, both PC1 and PC2 can't connect to the Internet. Upon completion of step number 2, Internet connectivity should already be successful. First to configure is BGP template. Click Routing, BGP, then Template. We will use the default and edit the required fields. Retain the name, then set the AS number. Configure the router ID for identifier. Click Apply, then OK. Next, create BGP connections. Go to Routing, BGP, then Connection tab. Click the plus sign to create. We will create BGP connections for each BGP peering for both ipv4 and ipv6. Let us start with ISP1. In General tab, set the desired name. Bind the BGP template. Then the AS number assigned to the customer. Choose the address family or AFI, which is IP or IPv4. Next is the peer IP. Then the remote AS number. The local role is eBGP. Enable Listen. Then Connect. In Extra tab, click Output Redistribute, then choose Connected and Static. That is all for the initial configuration. We will modify each connection when we go to BGP attributes for filter rules and policy. Click the BGP connection and copy to create new connection for the peering with ISP2. Modify the other details like comment and retain the output redistribute. Change the name. AS number and peer IP. Create 2 more BGP connections for ipv6, peering with ISP1 and ISP2. Retain the other details and change the comment, connection name, AFI, and peer IP address. Next step, advertise both ipv4 and ipv6 to BGP. Create address list. Go to IP, then Firewall and Address List. Click the plus sign to add. Set the desired name. Then input the network addresses. To advertise the prefixes, edit each BGP connection. Go to Filter tab, then change the default output network. In each IPv4 peer, choose IPv4 prefixes. While IPv6 prefixes for IPv6 peering. We are done with basic eBGP configuration and network advertisement. Before we proceed with the testing of connection, let us verify first the BGP routing table in session. Open both IPv4 and IPv6 routing table. In IPv4, we can see both the Internet routes with ISP1 as the default path based on the DAB or Dynamic Active BGP. This is due to all BGP attributes are the same, and lowest peer neighbor is the tiebreaker. The same status for IPv6 routing table. ISP1 is the primary path. In BGP session, we can also see more details like remote IP address, remote AS number, and other information for each established BGP neighborship. To test the connectivity, let us conduct ping tests both in the router and on the end devices. The customer's router successfully connects to the Internet using IPv4 and IPv6. The same result in PC1. In PC2, we need to add static routing for both ipv4 and ipv6 to their assigned IP network via CE1 as the next hop. Ping test in PC2 is now successful. In BGP, it is a good practice to advertise the IP prefixes to block hole or null interface in other network devices. To do this, go to IP, then Routes. Create new routes, then set the destination address and check the block hole. Do this for each IP prefix for both ipv4 and ipv6. In step number 2, we have configured basic eBGP configuration and network advertisement. The primary and best path is decided by the router based on the BGP default selection process. The next task is to configure BGP attributes to manipulate the customer's traffic based on the requirements. To accomplish our task, the first requirement is to set ISP1 as the primary path for all the inbound traffic, while ISP2 as the backup. To do this, configure AS-PATH-PREPENDING in customer's border router, which is the Mikrotik router. The customer's AS number will pre-prepended twice to make the path via ISP2 longer. A policy will be applied outbound to the eBGP neighborship to ISP2. In the Internet router, we can see that to reach the customer routes, the AS path length or hop count is the same. The lowest peer neighbor becomes the tiebreaker, which is via ISP1. Let us proceed and configure the Mikrotik border router. Click Routing, then Filters. Click Rule to add new routing filter. Set the chain and rule on the empty box below. In version 7, the rule implements a script-like syntax. First, create a rule for ipv4 prefix connected to PC1. Set the BGP AS-PATH-PREPEND value based on the requirements, then accept. Create another rule for the ipv4 prefix, connected to CE1 or PC2. Set the same AS-PATH-PREPEND value. Create two more similar rules for the ipv6 prefixes. Let us use the sample syntax on the screen. Next, apply the filter rule to both ipv4 and ipv6, eBGP neighborship to ISP2. For ipv4, click the BGP connection to ISP2, then click the Filter tab. Click the Output filter, then choose the ipv4 rule. Do the same configuration for the ipv6 BGP connection to ISP2. Let us go back to the Internet router and check the updated BGP routing table. The AS path length or hop count is now longer for the link via ISP2. We can assure that the best path will always be via ISP1 as long as the link and BGP session is established. The same status for both ipv4 and ipv6 BGP routing table. We are done and successfully implemented the first requirements. The next requirement is to make ISP1 as the primary and best path for all the outbound or request traffic. To do this, we will use BGP local preference and apply a higher value on the eBGP neighborship to ISP1. To configure, go to Routing Filters and add New Rule. Set the chain as LOCAL-PREF in, since we will be using this for both ipv4 and ipv6. See sample syntax on the screen. Next, go to the BGP connections and apply the local preference rule to the eBGP neighborship to ISP1. Apply the rule inbound. That is all for local preference. To verify, go to the routing table and click each dynamic routing entry of the Internet routes. The best path is still ISP1 with higher local preference. Let us do a quick trace route to verify the path. Both ipv4 and ipv6 prefixes of the customer chooses ISP1 as the best path to the Internet routes due to higher local preference. The next requirement is to make ISP2 as the exit point to reach Internet 1 routes. To do this, we will use AS-PATH filtering using a regular expression filtering the AS number of Internet 1. Go to Routing Filters and add New Rule. Create new chain name and use the sample syntax on the box. Set the local preference to 300. Apply the new rule to the eBGP neighborship facing ISP2 inbound. Go to BGP connections and apply to input filter. To verify, go to the routing table of Internet 1 routes entry. We can see that the new dynamic active path is now via ISP2, and the local preference value is increased to the assigned value. The best path to Internet 1 routes is now via ISP2 due to the higher local preference applied on the AS-PATH filtering. Last thing to do is to verify the failover. Shut down the interface facing ISP1 and make sure that all traffic will traverse to ISP2. Now verify the updated BGP routing table. We can see that all the routes is now via ISP2 only. The failover is working. With this, we have successfully configured basic eBGP and some BGP attributes to manipulate traffic in a Mikrotik router. I hope that this is informative to you, and thank you for watching.